Okay. Let me check Zoom one more time. Right. Let me share my screen. Right. So greetings, scholars. Greetings, YouTube. Let me see. So we are at the end of week 7. So what that means is that you can anticipate exam 2. I think I scheduled it for this to become available this upcoming Sunday at 11:11 a.m. It'll be due the following Sunday at 11:59 p.m. So it's just like exam 1, it's just exam 2. I'm under the impression that for this upcoming Monday, I think that's fall break. So that Monday and Tuesday, I need to confirm it. Once I confirm it, I'll send out an announcement, and more than likely we will not meet. We're not going to have the live session on Monday, but Pearson is just going to operate like normal. The main things that everybody here needs to be making sure that they're doing. 1 is completing their assignments on Pearson, and then 2 that everyone here has connected with Dr. Lamar and you've been following her instructions. I intend to calculate the midterm grade after exam 2 is due, right? So if exam 2 is due not this Sunday, but next Sunday at 11:59 p.m., then that Monday is when I want to try to calculate your midterm grades. And so basically the way I calculate midterm grades, whatever grade Dr. Lamar gives me, I'm going to scale that to 10% of your overall grade. And then basically the rest of the stuff I calculate like normal. Like if you didn't have a lab, then your exams will be 80%, your homework would be 10, and your quizzes would be 10. But so I'm going to calculate that average like normal, but then to combine Dr. Lamar's, I'm going to scale, that's the word I was trying to say. I'm going to scale that grade by 90%. So my portion is 90% of your grade, and then Dr. Lamar's portion is 10%, right? If I know that there are some students that they had a delay in gaining full access to Pearson. Again, so because of that reason, that's why, I made all assignments unlimited attempts with only a 10% late penalty. So even though everything has a due date, you can work on any assignment, including exams, unlimited number of times with only a 10% late penalty past the due date, right? So if you got to go back, just as a reminder, if you're trying to go back and make up an old exam, usually my exams, I think I set prerequisites where you need to score at least 70% in the corresponding quizzes, right? So if you're just gaining full access, hopefully you've been practicing on the while, and that way you can kind of hit the ground running, at least as far as Pearson is concerned, okay? So on Monday, we went through, I think we're wrapping up chapter 1, section 1.6, combining functions and composite functions. So today I want to take some time and go through as many homework questions as I can. Yeah, and I'm just going through as many as I can unless certain ones are requested. There was something else, but I can't think of what it was. So let's get the party started. And as always, this is remote asynchronous, so you're not obligated to stay. If you have questions, the recommendation is to feel free to unmute yourself to get my attention and ask your question. You can also type your question in the chat. I do check the chat periodically, but the audible thing is going to get my attention a lot faster, right? So in this first one, we're given this f of x and g of x, and we're asked to evaluate these functions. Now, initially when I was working these, I was, writing it out, f of 2, getting that answer, g of 2, getting that answer. With these, there's actually a shortcut, right? So if you have a graphing calculator, like I'm using a TI-83 Plus, right, emulator. So what I want to do is go to my y equals, and let's let the first slot be f, which is x squared minus 4x, okay? And then we're going to let the second slot be g, which is 6 minus x cubed, okay? I'm going to go back to my home screen. So for part A, we have f plus g of 2, okay? So that means f of 2 plus g of 2. So I'm going to call on these functions. And again, if I'm doing anything too fast, just you have to get my attention. F of 2 right? So that was the first slot. Then I'm going to say plus. Then I'm going to call on the second slot because that, nope, I hit the wrong thing. The second slot, because that's where we put G and we want to do G of 2, right? So instead of writing all that out for something like this, we can crunch it. We get -6, okay? Let's see if it'll allow us to type it. I want to go settings. I just want to turn this off. We got -6. Oh, that's good. Okay. So then the next one, we got G minus F of -3. So I'm going to go back to my variables. Whoops. Number 2, right? That's G. So we're doing G of -3 minus F, which is this guy, F of -3. Okay. And let's see, what do we get? We got 12. So let's give it a go. I thought I just turned you off. How are you already back on? Off. Okay. let's just do it, whatever we want to do. And did it, I was about to say, did it come on again? 12, right? Okay. Let's see. Yeah. Okay. So then the next one is F times G of 2. Okay. So I think that was let's call on the first one and change that addition to multiplication. And I think everything else is the same. We got lucky on that one. And so we got 8 there. Okay. And then G divided by F of -3. Okay. So then we can call on the one before this one and just edit it. So G of -3, instead of minus, it needs to be divided by. Divided by F of -3, okay. Integer or simplified fraction, let me hit math as a fraction. 11/7, okay. 11/7, okay. So we got lucky on this example that we were able to type it in. Now we don't always have that as a luxury, because when we look at this one, let's see if we can do the same thing. Let's see if something different happens. Okay. So now our F, we got 1 divided by the square root of x plus 5. Okay. And then we got 5x plus 3. Okay. Go back to my home screen. So we got F plus G of -4. So I'm going to call those up. F is the first one, F of -4 plus function G of -4, okay? Let's see, what do we get? Okay, we got lucky there. We got a -16. Okay. F minus G of 0. Okay, I'm just going to call on what I typed in and just edit it. So this is F of 0 minus G of 0. That says an exact answer using radicals as needed. So we get this long decimal. That means this one we need to actually work out by hand. Okay, so we need to work out B. Yeah, because that was made me concerned. After I finish this example, I'll check Zoom for anybody that's coming late. Okay. And we'll drop this here. Okay. All right. So we're working on part B. We have this F minus G of 0. Again, this means, oh, wait. This means f of 0 minus g of 0. Okay, so let's do those off to the side. F of 0 is going to be this x plus 5 inside the square root under 1, okay? And x in this case is 0, so then this ends up being 1 divided by the square root of 5. Okay. Then g of 0, 5x plus 3, 5x plus 3. Our x is 0, so that result is 3. So if we're saying f minus g of 0, then this means this is going to be 1 over the square root of 5 minus 3. Okay, that's going to be our exact result. Okay, so we got 1 over the square root of 5 minus 3. Here, 1 divided by the square root of 5 minus 3. Okay. Good job. We're almost there. So then C, let's see if we can do this with a calculator. F times G of -1. So let me call on, let's call on that first one. Okay, this one. F of -1 times G of -1. Okay. We got lucky. That one happened to be -1. Okay. And then D. Let's see if we can do it in the calculator. So it should be f of 1 divided by g of 1. We got a decimal, so that means we need to do that one by hand. Okay. So then D, and I'm about to check for the latecomers, A, B, C, D. We got f divided by g of, come on, of 1. Okay. This means f of 1 divided by g of 1. Okay. So then f of 1 ends up being x plus 5, x plus 5 inside the square root under 1. And again, x is 1 in this case. So this ends up being 1 over the square root of 6. Okay. And then g of 1, 5x plus 3, 5x plus 3, x is 1, so that's an 8. Okay. So then f divided by g is going to be 1 over the square root of 6 divided by 8. But 8 is the same as 8 over 1. So when we have one fraction divided by another, we do keep, change, flip. If we do keep, change, flip, ultimately we get to, we got this 8 times the square root of 6 under 1. Okay. Let's submit this and let's see how we're doing, and I'll check attendance. 1 divided by 8 times the square root of 6. Here, 1 divided by 8 times the square root of 6. Okay, press my fingers. All right, okay. So let me hop over to Zoom and check on you guys. Cool. Let's do like this. Okay. Let's see. There's this one. This one. All right, so let's do it. Let's keep going. Okay, let's keep going. Let me share my screen. Start the broadcast and let's hop back into it. Okay, so let's go into the next question. Given this F and this G, find these combinations. Now, I think this one we don't necessarily need to write it out. If I'm going too fast, you know, just get my attention and ask me to slow down, and I will. Okay, so I think this one we can just kind of do it in a little window here. If I can get it to activate. F plus G, right? We're just saying f of x plus g of x. So then this one should be 2x squared plus 5x plus 4. Okay. I just said f plus g. So then for the next part is f, oh, and then the domain, right? The domain of both f and g are both all reals. F is just a line, 5x plus 4. It's just a diagonal line. So that domain is all reals. G is a parabola, U-shaped curve. So that domain is all reals. So their intersection is all reals. So then most of these are going to be all reals. Okay, this one's going to be all reals. So then the next one is f minus g, right? So we're going to say f of x minus g. Now notice this minus is in front of the g, so there's nothing to distribute. So then I'm just going to write it out. We got 5x plus 4 minus 2x squared. Okay. And it's the same kind of argument as far as the domain from the first one. So I'm going to go here. Okay. F times g. Okay. So if we say f times g, it looks like we need to distribute the g. So then 5 times 2 ends up being 10x cubed, okay, plus 4x squared, okay. Let's see. Oh, 5 times 2, 4 times 2 is 8. Let's see. To be an 8. All right. Okay. So I'm just kind of doing the calculations here. Same argument as far as the domain here as the previous two. Okay. And then F divided by G. Okay. So then we're going to hit divide, which is this one. 5x plus 4. And then on bottom, G is 2x squared. Okay. That looks good. Now, the domain here would be all reals, but we have an added restriction where, again, we don't want to divide by 0. So we have to throw out any x that makes the denominator 0. So basically, we have to throw out x equal to 0 because that makes the denominator 0. So if we want to capture everything except 0, the only one that captures everything except 0 is going to be b. Okay. Let's go on to the next question. Okay. Given this f and this g, find these combinations and their domains. Okay. So for the first part, f plus g. Okay. So it's basically going to be x cubed plus 3x squared minus 4x plus 4. Okay. So F is a parabola U-shaped curve. Its domain is all reals. G is like an S-shaped curve. Its domain is all reals. So then their intersection is going to be all reals. F minus G. Okay. So then what I'm going to do is 3x squared squared minus 4x plus 4 minus x cubed. Okay. And it's the same kind of argument as far as the domain here, which is this guy. No restrictions. F times g. So let's distribute the x cubed. So then that's going to give us 3x to the 5. Okay. Minus 4x to the power of 4. Okay. Plus, that's not plus, plus 4x cubed. That looks pretty good. No restrictions in this case. Same argument. Okay. And then f divided by g. Okay, so let's do like this. Let's do our division symbol. F is 3x squared. That's not a 3. Ooh, went too far. 3x squared. Nope. Okay. Minus 4x plus 4 divided by x cubed. Okay, that looks good. Now, the only restriction here is, again, we can't divide by 0, so we want to capture everything except 0, and that's going to be this one. Check on you guys in Zoom. I don't know how that started. Okay. All right. Probably hit some button. Let's go back to the screen. So given this f and this g, let me see, there you go. Given this f and this g, same kind of deal, right? Let's keep going. So f plus g, okay? So this one's gonna be square root of x plus, our g is x minus 19, x minus 19, okay? Let's see. So the domain of f, we have square root. Remember, we cannot take the square root of negatives. So that domain is going to be 0 to infinity. The domain of g is all reals. So then their intersection is just going to be 0 to infinity. So 0 to infinity. Okay. F minus g. Okay. So then that's going to be square root of x. Square root of x. Okay, now we said minus g, we got the negative in front of g, so we need to distribute the negative. So that's going to give us a negative x plus 19. We had to distribute the negative there to get those terms. I think it's the same argument as far as the restriction, because we can't take the square root of a negative. 0 to infinity. Okay. And then f times g, we can distribute that square root. If we do that, we're going to have x times the square root of x, and then get out of the square root, minus 19 times the square root of x. Okay. And same restriction, we can't take the square root of a negative, so it's still 0 to infinity. F divided by g. Okay. So let's do our division. F is the square root of x. G is x minus 19. Okay. So we still have our restriction of 0 to infinity because of the square root, but now we also have to factor in that we cannot divide by 0. Notice that when x is 19, that makes the denominator 0. So that's an added restriction, all right? So it's still 0 to infinity, but now we have to throw out 19, and so it's going to look something like this. square bracket 0 to 19. 19 gets a parentheses because we get close to it, but we don't include that number. You combine this with a union, okay? And then we're picking up on the other side of 19 and going off to infinity. Infinity always gets a parenthesis. Okay. I feel like there should be questions. Let me check. That looks clear. Let's keep going. What's the time? Okay. All right, so this one we're asked to use the diagram to the right to evaluate g of f of x. So this is composition of functions. It means the second function inside the first function. A lot of times students confuse this open circle. They confuse that with multiplication. They start multiplying and distributing x's, and it just goes downhill from there. All right, so this one is the second function inside the first function. All right, second function inside the first function. Okay. So I'm going to start with the outside function. I'm just going to do it here. We got this 2x plus 5. But then inside of g, we put f. So let me back up to get to inside the parentheses. Now we're putting f on the inside, so x squared minus 1. And then let's just simplify, right? So I basically put f inside of g. If I distribute that 2, this turns into a -2. We got a 2 here, right? And then -2 plus 5 is plus 3. We're going to say plus 3 and get rid of this stuff. Okay. So now we can just plug 2 into that answer that we got. 2 squared is 4 times 2 is 8 plus 3 is 11. Okay. And then this one, same thing, just do -3. -3 squared is 9 times 2 is 18 plus 3 is 21. So that's 9 by 21. Okay. Oh, ouch. Owie, owie, ouch. Let's keep going. Let f be this and g be this. We're asked to evaluate f of g of -1. I'm going to try the calculator because we're evaluating, right? So my f is 5x plus 3, 5x plus 3, 5x plus 3. My g is 3x squared minus 2, 3x squared minus 2, okay? So now, let's see how to do this in the calculator. So my outside function is f, so let me call on that, which was the first one. Parentheses, the inside function was g, so let me call on that function, which was in the second slot. And we want to evaluate this when x is -1. Let me close off g, let me close off f, and hit enter. We got 8. Okay. All right, let's keep going. All right, f of g of -b. I think we can do it here. Okay, so f is 5x plus 9, right? And then g is 2x squared minus 6. So 2x squared minus 6, okay? Oh, but then we want to replace x with -b. If we do -b squared, it's just going to become positive b. So I'm just going to put b squared, okay? If I distribute the 5, this turns into a 10. 5 times 6 is what? -30. So it looks like that's going to be -21. And we add 9. So I'm going to say minus 21. Get rid of this. And I think we're done with that 5. Let's go with that. Okay. On to the next one. Let f be this, find f of 2. I'm going to use the calculator. Well, maybe we don't need it. 6 times 2 is what? 12 minus 5 is 7. So then take 7 and plug it back in. 42. 6 times 7 is 42. Minus 5 is 37. So that should be 37. Let's go 37. 37, no. Okay. F and G are given, and we're asked to evaluate f of G. Okay. So let's write out f. We got 4 divided by x plus 1. But now we're replacing x with g. So g goes on the inside. So we got 1 over x. Okay. I don't know that they'll accept it like this. We can get rid of the fraction within the fraction by multiplying the top and the bottom by the LCD of the fractions, right? So the LCD in this case is just going to be x. So we can multiply the top and the bottom by x. And it'll, I think that's how we simplify it, right? So let's see if I can get this to work. Okay, so if I go like this, come on. So if we multiply the top by x, we get this. When we distribute x across the bottom, this turns into an x, and this turns into just 1. Okay. All right, I think that's the best we can do. So then the domain. So now for the domain of a composite function, what you have to do is you find the domain of the inside function, then we find the domain of the simplified function, and then we take their intersection. The inside function is g of x. So that domain is everything except x equal to 0. The simplified function, we're dividing by 1 plus x, right? So we have to throw out x equal to -1 because it makes a negative, it makes a 0 in the denominator. So everything except 0 intersect everything except -1. Long story short is going to be everything except -1 and 0, right? If that makes sense. So we want to do interval notation where we want all numbers except -1 and 0. So then the far left is going to be -infinity up to -1 cup. And we're going to go from -1 to 0 cup. And then 0 to infinity. Come on. Okay. F and G are given, F compose G, and find the domain. Okay, so F is the outside function. Let me start by typing that. We're going to have the square root of x minus 3. And then we're replacing x with G. It's going to be 2 minus 4x. Okay. We can combine like terms. 2 minus 3 is going to be what? -1. Okay. Let's go with this. So the domain. Again, for composite functions, the domain is the 3-step process is first we find the domain of the inside function, then we find the domain of the simplified function, and then we take their intersection. So the inside function in this case is G, which is the domain there is all reals. For the simplified, we got this square root of -4x minus 1. That we remember we can't take the square root of negatives. So then, long story short, that -4x minus 1 needs to be greater than or equal to. Yeah, there it is. Oh, okay. Greater than or equal to 0, right? Okay. So then if I'm just kind of solving it here. If we add 1 to both sides, that happens. If we divide both sides by -3, the following thing happens. So then this is going to flip like that. And we're going to have a -1/3. Okay, let me get rid of all this other stuff. Okay. So if the inside function's domain is all reals and the domain of the simplified function is x is less than or equal to 1/3, all reals intersection, this is what you see on the screen, right? So x is less than or equal to a -1/3. So we want everything to the left of -1/3. Okay. So then to capture that, the far left is -infinity. Up to -1/3. And we're including 1/3. 1/3 gets a square bracket because there was a less than or equal to. Okay. Think about it. I might need to write it out. Oh, sorry. I think it's less than or equal to 0. You add, that was a 1. That should be a 1/4. I don't know where I got 3 from, just because I'm trying to do it here. That needs to be a 4. Let's try that, see if that fixes it. Okay. So everything we said was fine. We just should have put 4 instead of 3. Okay, guys. I think I'm done. That's it for me for today. Okay. All right. Are there any questions before we go our separate ways? So let me go ahead and make a copy of the work that we did. I'm going to make it available for you all to access on Box. Okay. Guys, call for alcohol. Any burning questions? Okay. If there aren't any burning questions, go ahead.
Can I talk to you in like a breakout room or?
Yeah, just give me a moment. Any other questions before we part? Okay. So if there aren't any other questions, since this will be private, I'm going to go ahead and end the stream. We're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay. All right. Let me see. Let me just put these guys in the waiting room. Okay, he's calling. Cool. Okay. Let me stop the stream.